I'm Brandon Shibley from Edge Impulse, and get started very easily to accelerate, simplify your Edge AI journey from anywhere from industrial devices doing computer vision to low power wearable devices working with time series data. We'll make it easy for you.
Fantastic. And because we've discussed it and you can find it in the video, it doesn't matter how much data you've got, because whatever much data you've got is enough for Edge Impulse, and you'll work it out from there. First of all, we have done quite a few videos with Edge Impulse, and I think we more or less all understand what Edge Impulse does. But Brandon, just give us a brief introduction for those that don't know. And then what we're going to do is we're just going to peel under the surface a bit and look at some applications, because Brandon's in charge of actually helping people take this technology, use it in the real world, so he can give you some insight as to the things that he's seeing every day with real customers, which I think is really, really important for us. So first of all, just an introduction generally about what you do. And then I think we're going to look at two application examples. I think you mentioned before we got chatting industrial and medical devices, and what those real world applications actually mean when you get underneath the bonnet and start using software. So over to you first of all for a brief introduction.
Great. So yeah, thank you. I'm Brandon Shibley. I lead a pre-sale solutions team at Edge Impulse. So really what we do is go and work with folks starting their Edge AI journey and getting to know about Edge Impulse. Edge Impulse is an Edge AI platform. It provides the end-to-end capability to ingest data, train models, deploy them, and optimize them for edge devices. So that's really what we specialize at. We make it easy. So folks using Edge Impulse makes it really straightforward for them to start building a model if they've got some data to make predictions on an edge device.
Okay, good. So what does that mean? So we've got this platform. We've got everybody now getting into Edge. Everybody trying to understand how they do processing on those Edge devices. They need to build models. They need to be able to interface with those devices. They need to understand what's going on. So when they do that, what are the things that you see? So I'm a design engineer, and I'm either probably watching this and thinking, no, I know exactly what I'm doing, and I don't necessarily need to listen to this video. That's fine. But I may also be somebody that's saying, okay, I'm tentatively looking into this world. I'm tentatively trying to understand what this world means. And it would be great to get your insight as to see what a day-to-day design engineer trying to solve the issues of Edge AI, trying to make machine learning working, trying to analyze what's going on. What are your day-to-day things that you see going on and you can help give people insight about?
Yeah. So, I would say it's a bit unusual that people already are kind of an expert at the full end-to-end stack there. Everything from
I was just making sure that those that did think that they were experts didn't need to watch.
Yeah. No, I
was being silly.
Well, it's the truth, right? So, there are a few blessed few that know what they're doing, but, most people are specialized in a particular area. And so Edge Impulse is great. We, in being able to make it simple end to end while still providing a lot of capable tools for, those experts in their area. So really what I do is, really get to understand the needs of somebody we're speaking to, understanding where the strengths are and, where they need a lot of help. And more than anything, understand their use case. So what are they trying to accomplish and work backwards from that? So the use case, what's the system concept that they have, and what kind of data are they collecting? And, it all starts with data ultimately. So we're looking at the data and trying to understand what kind of predictions are they going to be able to make with their data. And that can vary so we deal with anything from time series data, essentially any kind of sensor data. So whether that's time series type of sensors, you could think of IMUs or maybe a temperature sensor, or there's all kinds of things out there, or audio data or image data from cameras. And so we can deal with all that kind of stuff, but really we need to understand what kind of data is there, how does it apply to the use case? And then we can talk about how do we get ingest data? How is it labeled? Labeling is obviously important to be able to train models, at least the majority of the models that we deal with. And then ultimately we want to understand how much of what kind of package is this going to go into? So is this a device that has a lot of processing power, or is it low power? kind of budget do we have to work with? And so Edge Impulse also provides like tools to help with profiling models and helping optimize the model down to very resource constrained devices. So that's in a nutshell the very basic gist of it. But there's all kinds of subtopics that we can deep dive into. That's something we start to understand, like, where are the challenges that somebody's facing, where are the areas that we need to go and like maybe do some deeper consultation
Yeah.
and
So
dive in as needed.
So what you've described, and I think you're quite right to say, actually, no one's an absolute expert in any of this because it is all very new. When you've talked about the three kind of sensors that you're going to get data coming in from, that an engineer would obviously understand the bringing in of the data, the processing of data, and then you've talked about, how do you integrate the machine learning, and because you said it was all about data. When you go to analyze and when you go through that process then of doing the AI on the edge, as you just said, for many people this may be the first, or at least you haven't been doing that for a year probably, or maybe you've been doing it for the most 18 months. For the vast majority of people, this is quite a new thing. What's the intuitive process that you're able to gain from Edge Impulse? What's the intuitive bit that enables them to be comfortable? What's the user experience? And I think what I'm asking is, what's the user experience that will make sure they go, hang on a minute, if I go and explore Edge Impulse, this isn't going to be scary because it's designed to help me use it. So what happens when I first start doing that? When I first start interacting with you, what happens?
Yeah, when you sign up for Edge Impulse, you get a walkthrough. So it really walks you through, this is how it works. It all starts with bringing some data in or collecting some data, designing what we call an impulse. An impulse is really not just a model, but it's also pre-processing that we do on data to perform feature extraction. Understanding your data and being able to extract features from it in order to, you can think of it like maximizing the signal to noise ratio, right? Data it's got some signal in it. It's also got noise in it. And in order to build, small optimized models, it helps if we can, maximize the amount of signal we're getting out of the data, and kind of get rid of anything that's not so important. So that's, feature extraction is a really important part of that whole process. But it's part of that impulse that leads into training a model. But then also this impulse we can compile and optimize down for target hardware and deploy it onto a device. So that same, that impulse, it's like a processing pipeline, is used for both training a model, but also is what gets used at inference time on a device for making predictions. So we try to make that really simple. It's like, you construct this with sort of these blocks. You can think of it as kind of a low code interface. However, we also have the ability to go in and write your own code, modify the code of these blocks. So the default experience is pretty simple. Really, anybody could approach it. If they have some data and they can sort of understand what they want to do with the data, they can start building models with Edge Impulse. But also for those folks that are more expert, we provide the ability to go deeper, get into the code, really modify, model architecture, write your own signal processing for feature extraction and things like that. Once the impulse is built and trained, then you need to be able to compile and deploy that onto actual hardware. And so that's kind of the last step there, which is really, we make it very easy. As you can imagine, without Edge Impulse, the default experience is you got to figure out, from the universe of possible tools out there in the world, what are you going to do, use for things like machine learning? How are you going to process the data? How are you going to train a model? And then how are you going to compile it for a device, which, to be honest, a lot of the documentation and tooling around some of these chips is maybe not as user friendly as we'd like. So Edge Impulse essentially abstracts a lot of that away, and we make it really easy. It's also great if, you can imagine we support a lot of different hardware. We partner with a lot of great silicon companies to provide support for their chips. Makes it really easy to also move between different chipsets. You can also use our profiling capability to understand how well is this model going to run on that hardware, and maybe use it as a way to compare different hardware. So, that's the basic experience. But I will say one other point, which is super important for machine learning, is experimentation. And we try to make experimentation super easy as well. So I talked about the impulse how to get data in, train an impulse, deploy it. But you want to, you're rarely going to get the ideal result on the first attempt. So we also think about how to make experimentation really easy, trying different types of models, different forms of feature extraction, playing with different parameters and hyperparameters. So you can construct a lot of experiments and compare them, the results in terms of the accuracy of the model and the performance on the device. But then also it's automating that with our AutoML tool, Eon Tuner, so that you can essentially define like what's the range of possibilities I want to go and explore. And our tool will help like go and help you explore and run those experiments automatically.
Right. So when you so your hardware is already decided and you're partnered. I don't know how many silicon vendors you're partnered with, but it's a lot. It's how many is it? How many?
Well, I don't have a number, but
It's
a lot of companies.
I mean, I'd challenge anybody to find a mainstream silicon vendor that's not partnered with you. So, yeah, you've got to have gone very left field, or as I like to say, off planet, to have found somebody that you're not already associated with. So you describe modules that are already predetermined, and then those modules have already been predetermined, so they'll quite happily link in with the silicon that you decided is your hardware platform. So those two things will automatically speak to each other. So you're going to be relatively comfortable with that when you start playing with the software. And then just so we're clear, you talked about experimentation. So then once that's done, so you can start doing things. You describe those 4 processes that are the basis of integration, and then you give the, for want of a better phrase, the sort of analog experience of being able to do your own thing and experiment on top of those things. So if we can just now talk about just as a typical example within, if you could just talk through, I'm an industrial designer and I'm dealing with computer vision and I want to build a model. Just explain to me what are we don't need to make this long, just so that somebody can feel very comfortable in saying, yes, that's me. They understand what I'm doing. Just explain how that typical process starts and some of the themes that you see going on in that industrial computer vision area for machine learning, and how your platform helps integrate all that.
Yeah. Like I said, it all starts with the use case. So when you talk about computer vision, the first thing to understand is like, again, what could be predicted or what kind of problem are we trying to solve with computer vision? And so, common examples might be like inspecting things, like either on like a production line or maybe out in the field, so forms of inspection, looking for defects. Other types of use cases could be like detecting objects, looking for certain things in the world, or classifying. So there's a lot of different types of use cases. We need to really understand what that use case is, what we're trying to solve for, and then ultimately come up with a design to achieve that. And again, starts with data. So that's one of the very first things we usually talk with folks is like, do you have data today? And is it representative of what you're trying to see when you go and deploy this thing? And so sometimes that's where we have to get to work. Initially, it's just, let's make sure we can get some more high quality data.
Yeah.
That can be a blocker for a lot of folks. So there are some strategies there that we can help with. Yeah, go ahead.
Sorry. No, I've been criticized on comments for interrupting, so I shouldn't interrupt, but I just did. So I apologize to anybody that was going to write in the comments, he's interrupting again. I apologize to you, whoever that is that wrote that comment. So what's the first step to good data then? I think you were going to explain it anyway, but I wanted to make sure, because you almost described that, you were almost saying it always, you right at the start of the chat said it's all about data. So that's great, of course it is. But then you said, then when we go deeper, we find that actually it's the data source that is the problem. So how does somebody go about getting better data? I mean, they wouldn't have started this process unless they thought they had good data. You're saying it's all about the data. So what are the common mistakes that people make in industrial computer vision that means that they don't give you the starting point that you need to start analyzing it and creating the model that they want?
Yeah, I mean, honestly, I see kind of a tendency to err on both sides of this challenge, which is either not understanding that you need some data to start, or believing that you need like a universe full of data in order to get started. And the reality is you just need some data. It should be representative of the problem you're trying to go and address, but it doesn't have to be, let's say an extreme amount of data, right? So a lot of people will think, oh, we need 6 more months to just go collect data. And I think that's generally not necessary. You can start experimenting with even small amounts of data. But what you should have in place, and this is what we like to help folks with, is like a way to continually collect more data. If you can get started with
Okay.
some data and then be on a path to where you can continually get more data in. So you train some initial models. They may not be very good initially. That's okay. It's as long as you have a way to maybe test them and collect new data. And a lot of times, once you start getting some models going, they can even be a tool in labeling new data. So even though they're not perfect, they are better than nothing. And they'll help speed up your process of being able to like label some new data. Obviously, managing data is extremely time intensive to do it manually, where people are manually collecting, labeling, validating data. It can be, it's often one of the most time consuming parts of the whole project. So any way that we can automate that, that's better. So we have tools that help with data ingestion. We have tools that use AI to label data, to help with validating data. And we also can synthetically generate data as well as augment existing data that you have. So there's all these different levers that you can play with to get more out of the data that you have. And so that's step one, right? We have some data. And then if we do, can we amplify it in some way using some of these capabilities and just make sure that we also create pipelines that help with continuous data ingestion. So I think if we can do any of that, we're in pretty good shape. It means that we're on a path to where we can start training models, and we'll even be able to continually improve them as we get more data. That makes sense?
It makes complete sense. Do you see difference in industrial apps? So I just used, because we started talking, we said we are going to go into application examples, so that's what we'll do, because that's what we promised we'd do. So you've just described a really good computer vision industrial. Do you see, just because they're two very different applications, but they're typical machine learning type environments where you're going to be wanting to train a model to do something, is there you've made it very clear that you've got to start with data, and let's just start with some data, and there's not a tipping point, so they just start because you can learn from that data, and you went through that very well. Do you see any differences in consumer or healthcare in different ways, and how different ways your platform interrogates that data in different applications? No, I'm the one who gets criticized. I'm the one who gets criticized for interrupting. So don't worry about that. You just keep talking.
All right. So there are both similarities and differences. So you rightly kind of alluded to, in industrial, we see more computer vision, but that we still also see audio and time series models and stuff as well. And if we look at a different area like wearable health devices, tends to be, because these are low power things and they're looking at like maybe bio signals, they tend to be more like low power, looking at time series data and things like that. But, there are still some common challenges in terms of like getting good high quality data. It can be expensive. Industrial, for example, you might have like a bunch of sensors, let's say in a facility collecting data. That's great. So it's probably giving you a lot of like normal looking data. But if you're trying to predict, let's call it defects or failures, then you would like to have some of those examples to train with or to test against. And so one of the challenges is that it's easy to get some of that normal data, not so straightforward to get maybe examples of all the ways a system could fail or all the kinds of defects that you might see in a production environment. Usually the first step is training something like an anomaly detector. It can be trained on just normal data. And then the idea is anything that's outside of the norm, at least outside the data that's been trained on, it's going to flag as an anomaly. And so that's a great first place to start, because you just need some of that normal data. Now it might start triggering on things that aren't exactly, let's call it defects, but they're just maybe conditions that have changed in the environment. It might also not get triggered on some things that you would consider to be like failures or defects. But, you've gotten a place to start anyway. And as you continue to collect data, you can look at the results and see where they differ. label the new data coming in, train a better model, and just iterate on it that way. And then at some point, as you start to get examples of defects, you can train other types of models like classifiers that have been trained on examples of defects or failures and can even classify them.
Right.
So that's like maybe a typical journey there. When we look at wearable health devices, again, still a similar challenge of getting good data. Like they may have gotten a lot of clinical data on what normal looks like. But you also want to be able to get examples of maybe what abnormal looks like. You're trying to maybe predict some kind of health condition, then you will need some examples of that. Even though you can train these anomaly detectors on normal data, you still want to be able to test them against real examples of the types of conditions that you want to catch. So, yeah, that's one of the common challenges across any verticals is getting examples of all the things that you want to be able to see in the real world. And so you can use augmentation techniques. You can synthetically generate some of these scenarios, even simulate them in a physical environment in order to get this data. So we've partnered with NVIDIA on Omniverse. We've got a plugin so that you can really simulate in a realistic 3D environment and collect data and then use that data to train models that you can then deploy models not only just into the real world, but also back into the simulated environment for testing purposes. That can be the other expensive part, is testing these models and seeing that they work across all those different conditions that you want them to be effective in.
Yeah. So I mean, how does, just because you mentioned it, so I just want to come back to it. You mentioned low power. Are there implications with if you're in an industrial thing, looking at boxes going through, you're connected, you're not low power, you're not a small device. Is there a difference between, from your point of view, collecting data on a low power device? What are the implications of a low power discrete device versus a connected big device? One's very stable, one doesn't rely on power. No, it relies on power, but it doesn't. The data coming through to it is going to be very consistent and reliable and stable. But you made a point about low power. So is there a difference between low power data in terms of learning, and are there different implications? Because you did make a point of that. You did actually say low power. So could you just go through the low power implications of something like a wearable and how that affects the learning models?
Yeah, absolutely. I mean, something we didn't really get into yet are why even put models on the edge in the first place. And one of the reasons why is, first of all, power, and maybe you don't have connectivity all the time. You're alluding to these things. Could also be for privacy reasons or because you need real-time responsiveness in the system based on the predictions and so on. So when you look at an industrial environment, you may have persistent connectivity, not always, but it's usually easier in that kind of facility environment to have stability, as you mentioned. And also you usually have enough power. But the reasons why you might put the model there is because you need real-time responsiveness. You might, in some cases, there actually is concern about sending data over the internet. Some of the data in those environments is sensitive. On the wearable low power device, obviously you may not have persistent connectivity. There's no other way to do prediction besides do it on the device. Also, we can reduce power by putting the intelligence as close to the sensor as possible. And so what you're doing with machine learning is you're taking a bunch of data, you're continuously ingesting data, and then making a prediction. So the amount of data immediately gets massively reduced from this big stream of real-time continuous data to predictions, oftentimes on we can say we can label that data and maybe it's effective over a much longer period of time. The point being that we can compress the amount of data very close to the sensor. That's going to save data or save power basically any point beyond that in the processing chain. And so that, and especially because a lot of the silicon going into these very, resource or constrained or power efficient devices has gotten so good, we can run these models with very low power consumption. And our tools are really great at being able to optimize them for that resource constrained environment for power optimization. So yeah, the first thing you were asking about is how does that affect the data? For one, we're trying to do that data reduction as soon as possible. That can make it challenging then to ingest data from those devices for training because, first of all, they may not always be connected and sharing their data. And secondly, we're trying to actually reduce the amount of data from the very start. But, within certain environments or under certain conditions, for example, maybe when there is plenty of power, when there's great connectivity and so on, that's a good time to be ingesting data from those devices. It's always great to get new data. As I mentioned, you want to be able to continuously ingest new data to continually train better and better models.
Yeah, I think what I take from what you've just said there, which is why you mentioned low power and you talked about discrete edge AI devices rather than connected, stable environments like industrial applications, is that your platform and your machine learning environment is totally, it's able to adapt to both of those environments, and you have solutions to both of those environments, and they are equally, I love the way you describe it, massively decreased. I love it when people say things like massively decreased. How can something be massively decreased? I love sayings like that. But they are equal and opposite applications, aren't they? Where one, they're lots of data, there's not the restraints on power, there's not restraints on bandwidth, you get all the data coming in, but you described how even that can still be, you have to be very protective of that kind of data. It might be sensitive in some way, so that there are issues there. And then you go to a small little wearable like the thing that's on my wrist, where it's not connected continuously. It only has a certain amount of power. It's taking in data from the sensor very closely. But what you were saying is that your platform is very comfortable sitting in both environments and doing very different jobs at the opposite end of the spectrum. I think that's the most important part of answering that question, which is you have adapted what you do to both of those equal and opposite environments, which are massively decreased. No, they're not. That's just me being silly, but I know what you meant when you said that. So yeah, that is very interesting, because those are two completely opposite ends of the spectrum regarding data. And as you said right from the start, this is all about data, data, and data. But don't be afraid to think that you need 6 months or a year's worth of data to start. You can start at any point, and then you can create data even when you don't have data, which is what you described, synthetic data, which I love when we start talking about things like synthetic data. And we're going to then start talking about digital twins, and I'm going to get really confused. So we're not going there. But anyway, that was a very good discussion about how you can get started with Edge Impulse to start doing machine learning with your platform, how you shouldn't be afraid, how you can start at any point with data, and it doesn't matter whether your application is an industrial where you're connected and the power doesn't matter, or you're on a little wearable device where the connectivity is discrete and the power is low, and you can quite comfortably do your machine learning and understand those two different environments and just get started. So Brandon, that's been a very good discussion, understanding the different applications for machine learning using Edge Impulse's platform. And we heartily invite everybody to go and play with Edge Impulse and start learning about how they can understand what's going on their devices. Thank you very much.
Yeah, thank you. It's been a pleasure, Guy. And as you said, it's so easy to go check out. So I urge you to do so. Studio.edgeimpulse.com. You can sign up and give it a try today.